it requires might dictate which of the options we select, but running 2 cells would give us more staffing flexibility. So let's select that option. Now we have 2 cells running with tracing and adhering done by the same operator. Let's measure the output cycle time of each cell, starting with the cell on the right. Output of the cell, output of the cell, output of the cell. This cell is producing at 13 seconds a unit. Now let's look at the one on the left. Output of the cell, output of the cell, output of the cell. This cell is producing at 13 seconds as well. With 2 cells producing a unit every 13 seconds, we effectively have a unit coming out of our operation every 6.5 seconds, which meets our takt time of 7.5 seconds. Now let's measure the product lead time. If customer 2 orders a unit, will they get it in 30 seconds? To measure this, we'll select a color to follow through the process. We'll select green. As step 1 grabs a green sheet, we'll start the clock. Now we watch it as it goes through the entire process, tracing, cutting, adhering. When adhering is done and puts it into the completed pile, we stop the clock. In this case, our lead time was 21 seconds. Because our customer needs these orders within 30 seconds, a 21-second lead time will be sufficient. If our lead time was greater than 30 seconds, we could value stream map the process to look for ways to eliminate inventory. We have looked at 2 different scenarios: calculated takt time with different volumes, measured cycle time to see if we are meeting our takt time, and measured lead time to see if we are meeting our customer's SLA. Now that you understand how to measure your process with takt time, cycle time, and lead time, why don't you go and measure your own process? You might be surprised at what you find.